Imagine a vast, hidden reservoir beneath your feet, supplying countless homes and ecosystems with essential water. How well protected is this precious resource from what happens on the surface? Recharge significantly affects unconfined aquifer vulnerability by acting as the primary mechanism through which contaminants from the surface can reach and pollute the groundwater. In an unconfined aquifer, the water table forms the upper boundary and is directly exposed to the land surface. When precipitation or surface water infiltrates the ground, this process is known as groundwater recharge. As this water moves downwards through the unsaturated zone, also called the vadose zone, it can carry dissolved substances and suspended particles along with it. A higher rate of recharge generally means a faster downward movement of water, which can accelerate the transport of contaminants to the water table. Conversely, very low recharge might allow contaminants to accumulate near the surface, but the direct transport pathway to the aquifer is less active. The physical properties of the soil and rock layers above the aquifer also play a crucial role. For instance, highly permeable soils like sand and gravel allow water to move quickly, increasing the speed at which contaminants can reach the aquifer during recharge events. Clay-rich soils, while slowing down recharge, might also bind certain contaminants, potentially delaying their arrival or reducing their concentration. Understanding the local geology and hydrologic conditions is therefore paramount when assessing vulnerability. When evaluating vulnerability, hydrogeologists consider factors like the depth to the water table, the type of overlying materials, and the land use activities that generate potential pollutants. For example, an unconfined aquifer with a shallow water table, sandy soils, and high agricultural activity is far more vulnerable to contamination from pesticides and nitrates carried by recharge water than a deep aquifer protected by thick, less permeable layers. This intricate connection between surface water, the vadose zone, and the unconfined aquifer highlights why effective land management and pollution prevention are so critical. By carefully monitoring recharge rates and understanding the subsurface characteristics, we can better predict contaminant movement and implement strategies to safeguard our precious groundwater supplies.
If you love learning about water, like, subscribe, and keep exploring with us.